plugin base design, so it can now support over 40 task time and over 11 data source and supports many alert system and some legislation. So the last word, the powerful digital interface, it means it's drag and drop first. So it's very user-friendly, and it can also support Python API and OpenAPI for the workflow management, and also can support YAM definition. So it's also engineer-friendly. Okay, so a little bit about the DolphinScheduler history. So DolphinScheduler was first created on 2017 only for internal use, and then it open source in 2019, and the same year it went into the Apache incubator, and it the first open source version, and in 2020 it reached over 500 users and 100 contributors, and then he released 1.3.9 version and include the SPI transition task, and on 2021 it released the 2.0, and 2022 it released the 3.0. So right now the latest version is 3.1.8. Later we will introduce the feature of this DolphinScheduler. Okay, for DolphinScheduler, the biggest advantage of the DolphinScheduler is its agile and flexible workflow management. You can use drag and drop, or another word is what you see is what you get for the workflow creation management, and also as I mentioned before, you can also use Python or YAM to generate the workflow, and also use API. So it's suitable for both developer and non-developer. Okay, and as a data engineer, we also need to we have a lot of detailed job. For this job, we can categorize into three parts. One is the batch, one is the streaming job. For most of the workflow platform, we support batch job. So DolphinScheduler can support batch job. So it supports many circle data source, and supports Flink Spark streaming. So DolphinScheduler can be one place big data workflow platform. So another thing the data engineer care about is the data quality. So DolphinScheduler has built-in data quality support. It has built-in over 10 data quality rules, and it supports custom circle chat, and so it can seamlessly integrate into the workflow. This feature can improve data quality with minimum operation cost. Another benefit is that DolphinScheduler supports MLOps. It integrates with Kubeflow, MLflow, SecondMaker, and DBC, and other local platforms like Jupyter and the ML Flavor, PyTorch, OpenMLDB, and etc. And also, DolphinScheduler is also cloud native and extensible. It supports Docker and Kubernetes. It supports Kubernetes tasks, and Also, if you are a Java, you can use the SPI to define your own task time. You can, okay. In the coming future, DolphinScheduler will release the 3.2.0 version. Here's the feature. There's a lot of feature and enhancements. So here I would like to highlight some of the features. The first one I want to highlight is this. It supports a more data source. One of the data source is the OceanBase. As As our last speaker will talk more about this database, and also add more task time, and it supports remote log from OSS and GCS and AWS 3, and then it can also support getting real-time log from the Kubernetes pods. These features can enhance the log, the debugging. Okay, another open source workflow platform is Apache Airflow. I think maybe some of you can also know this project. So here I would like to have a comparison with DolphinScheduler with Airflow. So DolphinScheduler is written in Java and Airflow is written in Python. And the other feature I want to highlight is that as a data engineer, sometimes we need to backfill our data pipeline, and if you're using Airflow, you can only do it using the command line. And if you use DolphinScheduler have the UI support for backfill. And I think in terms of a Python developer, I think most people they will choose Airflow. And if you are a data engineer and you're familiar with Java, maybe you have some of the users they not developer, then you think you can choose a different scheduler. Okay, you go to our demo. Here's the UI for the DolphinScheduler. Okay, you can see this. It lists all the task state, the state of the task, how many tasks success, how many failed. And for our demo, we need to create a data source to connect to our OceanBase. I already just OceanBase database from this OceanBase account, and then I create this data source. If we want to create a new data source, we just create here, and then for now the coming new version will support this OceanBase data source, and OceanBase can support because OceanBase supports MySQL protocol. So I choose the data source type to MySQL because right now the OceanBase data source type I think still have some problem. So I can show you so here we choose MySQL, and then we fill in the IP port and use the password. And for the data source, we need to define it in pair. One is for testing, one is for the production. And for here I defined the test and production using the same database. Okay. And then after define this data source, then we can create tasks to connect to this data source for our job. But first, if we want to create a platform, we need to create a project. The workflow is under the project. So here I already create one project for demonstration. Here, then we go to this project page and we have this workflow definition. Here we can create a workflow. And after creating, you create a workflow, you can check the let me create a new one. Okay, you can check the task type, and then you can create a node. Then here I create a shell task, and then you can create another more task. Then you can define dependency. So here's the way you create a workflow. Then you can, after you create this workflow is not active, so you need to make it online active this, and then you can trigger the task. Okay, so here I have created two circle tasks before in this workflow. Both of these nodes are connected to the OceanBase data source. You can see this, because this one is already active, so you cannot change the task. If you want to change this, you need to deactivate the workflow. So let's just look at the definition of this task. And this, at first I defined a task called node 1, and then I choose my circle data source type, and then choose my data source. The data source I defined, and here the circle type is query. So here I import a very simple slash circle statement. Okay, and then this name can output to the downstream task node 2. So here, because I define this custom parameter here, and for this node 2, it's also a circle task, and I choose my circle data source type and choose the same data source, and then this time I choose the circle type to non-calling, because I will update the database, and then this is the parameter passed out from the first task. Okay, after you define this task, you can define the dependency, and then let's go back to the definition here. Then you can active or online this workflow, and then after you online, you can manually check, or you can define the schedule for this workflow. Here we just manually check this workflow. For check this workflow, you can choose whether you want to run the test. If you run the test, if you use the test data source to run the task, you just run in the production. Then you can check the workflow instance. Here you can see that the task already finished. then you can see that the log one. You can double click, and then you can see the log here. So here's the slash statement. Then we already. So the name is not the result is registered, and then we will pass this variable, this parameter to our downstream task. So can check the log of the task too. Here the name is int parameter for this task log 2. Then we search here. Okay, then the task is run successfully. Okay, and so this is the demo for how to run a several tasks to connect to OceanBase data source. Okay. Next, I will talk a little bit about the DolphinScheduler community. Right now, DolphinScheduler has so many users. Many companies are using DolphinScheduler like IBM, Dell, and Novo, Tencent in China, WPS, and Xuying, also Walmart. And DolphinScheduler has integrates for so many big data and ML machine learning frameworks. Also integrates with many cloud platform like AWS. Okay. If you want to know more about DolphinScheduler, you can check the link here. Okay, that's all for my sharing. Thank you.
Big thanks for Kyle to share his insight. Let me introduce our next speaker, Tommy. He is highly skilled in the field of database. He accumulates years of experience at Oracle and AWS. Let's warmly welcome Tommy.
Thank you very much, Carl, for the presentation. I do see a difference here. I actually used Airflow before. I have not used DolphinScheduler, but after your presentation, I feel like I should use it. And the main reason is that if you look at the comparison, just from my perspective, right, the difference is that one, you have a UI. And Java and Python, of course, Java will be more performant. That's one. Another one is that I noticed that actually we also do machine learning as well, especially on the Python and streaming. Streaming is actually now in trend, right? So the way I see it is that in my mind you can do like inference, right? You can capture image, you go through the processing, and then you are able to do inference, and then after that you got the results is stored in the S3, for example, because there's AWS object storage, right? Yeah. So that also leads us to OceanBase, and thank you very much for Carl to actually put up the demonstration on the data source with OceanBase. Actually, OceanBase can do two things here. One is as a data source for DolphinScheduler. Another one also I've seen the announcement now is that as the metadata storage, right, for DolphinScheduler as well. So just a little background on the database trend and what's the critical demand, right? So if you look at here, we are almost at the end of 2023 now. And we're looking at these are zettabytes, right? So there's gigabytes, there's terabytes, there's petabytes, and I think next up is zettabytes. There's a lot of data there. And you see that in 2023 we are going to hit 101 zettabytes, and in 2024 we go to 132 zettabytes. But this chart is before the emergence of generative AI. So when we came up with this study, it was like way before that ChatGPT comes on. And if you look at the trajectory of data that's coming in, it's going to go beyond this number, right? And that brings in additional challenges for complex data requirements because you've got larger data volume, stronger capabilities requirements, and the transactional volume is higher. Another thing is that you also want to do like more and more data analysis. So traditionally, I came from this traditional background where there's commercial databases. You focus on individual standard database where the standard database is one monolithic, huge hardware where you put in a database platform and then you upgrade it over time. And then of course, eventually this massive monolithic hardware. The hardware could be, old days it would be the mainframes. I'm old enough to know mainframes like the IBM 390s. And then you have the AS400, and then move on to Unix systems, right? Solaris, HPUX, and so on. So eventually you get to a point where you just cannot keep going up, and you expanding your hardware is going to be really expensive. So what the vendor as also the engineer has decided is that okay, we can shard the data. So rather than one single monolithic database, now I have 10 shards that actually forms the total data usage, right? There are some benefits and disadvantages there. As one is that yes, you can shard the data, you can distribute it, multiple databases holding on all your end-to-end data. However, whenever you need to change the structure, you need to modify the layer that actually interacts between the application to the middleware and to the database. So that's actually quite challenging to do. And that's where, if you look at the trajectory of relational database, right? So all we have here is relational database. You got, we start with Oracle and then DB2, of course, SQL Server. I started with SQL Server 7.0, and now it's SQL Server 2019 now, I think. And then, of course, we got emergence at the same time, we got emergence of the open source platform. And we started with Postgres. In 1996, there's the MySQL. So there's an emergence of the relational databases from both the closed source and the open source platform. And then when we hit towards the 2000, the time in 2000 where, we start to have digital economies, digital services, Amazon.com, and then of course Alibaba. And then you realize that, okay, the kind of transactions volume that we need is exceeding the traditional solutions. So then we start to have this distributed database solution here that, we think about the design that you are thinking is that, okay, you definitely need a lot of transaction volume, you need a lot of storage, you need a lot of capabilities to store the data, and it's easier to distribute it out, right? So then you have distributed technology. And here's where, we start our journey as OceanBase. So we are not really a new database platform. If you use Alipay now, you use Taobao now, and Alipay doing billions of transactions every single day is powered by OceanBase. And when we started, we really started with this concept of Double 11. So Double 11 said, 2009, we say, hey, what about we have a Double 11 festival, right? And then we realized that it was really successful, and we had a lot of transactions, and then we also encountered like significant challenges with our database. So in 2010 onwards, we got one of the most top elite scientists in China says, let's focus on this problem about handling massive amount of data. And his concept is that, okay, one single machine cannot do it. So let's design the database to be distributed architecture, right? So we started that distributed architecture since 2010. And then, over time, we built more and more capabilities. So initially, we just wanted to be able to distribute out the capabilities to do queries, to do transactions. And then, once we know that it's a stable platform, we start to actually store financial transactions. So where you see 2014 onwards, we actually use it at Alipay as well. And then, of course, over time, our ecosystem partners, right? The likes of wallets, the likes of your banks, they say, hey, this is really a fantastic piece of platform and technology that I could use as well, because if you are doing millions of transactions, I have to handle millions of transactions as well. So then you see the wallets, and then so it's all in Chinese, but basically these are the banks. And of course, afterwards, there's all the rest of the downstream ecosystem service providers that say, hey, I'm an insurance company, and now I'm actually doing online insurance policy transactions, and then I also need this kind of transaction volume as well, and it's really, really massive, right? So towards 2019, we're getting more and more customers to use that. Now, actually, even from this point onwards, we already have customers external, they're starting to utilize our technology. And then you can see that, towards this way, you can see that we start to have external, like ASEAN payment service providers that's using us. You can see Dana is here. So Dana is, at the moment, have 150 million users, and it's doing 13.5 million transactions every single day. And it's all powered by OceanBase. So another, of course, once we go towards like year 2020 onwards, so Ant Group decided to say, okay, this is a valuable technology that we really want to introduce to the world. And we started OceanBase in 2020, and then in 2022 we started OceanBase Singapore, which is where I'm based. Right? We are the regional HQ, and then our focus is really to start distributing this really fantastic technology to the rest of the world. And then you can see that coming from that angle, we got GCash as well, who is a really large major payment service provider in the Philippines is using us, and I'm visiting them next month to actually looking at how they're using our technology and see if you can actually expand more usage, right? Okay. So now this is just some of the leading standards that we have achieved so far, right? So OceanBase was the first one of the distributed database that actually went on the TPC and hit TPC-C record and also a TPC-H record. So what is that? Transactional, what is analytics? And also, we came up with this really unique solution. Initially, when I joined OceanBase, I have no idea what this means, but it really means is that not only you have a single layer of potential, you have multiple failure modes, right? So you got 5 data centers in 3 different cities, but in Singapore, first off, I'm only one city, right? So it could be 3 different data centers, right? Or 5 different data centers in 3 different locations, sorry. And then what it does is that it actually allows you to have 3 different failure modes, right? So if you have one failure, it fails over and then it doesn't affect your transaction. If you have second failure, it fails over again, it doesn't really affect your transaction. But if finally you have the final failure, there's still capability for your system to serve like 50% of your traffic, and you can still have time to go and restore your system, right? And we designed this because in certain regulatory compliance environments, say in China, at any point of time, you can only have 5% of the system go offline. And within 15 minutes, you got to bring it back up again, right? Otherwise, their infrastructure is going to be in trouble, for example. And another thing that is unique from that 5 data center and 3 cities concept is our return to operation is actually really fast. So in version 3, we could already do within 30 seconds. If one of the nodes fails, it cuts over, it could do it within under 30 seconds. And with version 4, we could do it in 8 seconds now. So it's pretty fast. Okay, so this is a journey that we've been on, and I think we are at a pretty interesting place now. We used to start with really big customers. So Alipay was a really, really big customer. And then we started to say, okay, we optimize the resource a bit, optimize the architecture a bit. We could do medium-sized customers now. And then what we wanted to do is that we wanted to create that ability for startups to actually do that acceleration path, where they can start with a small deployment of OceanBase, and then you can go from small to medium and to big customers, right? So a couple of ways to do this. One is that, of course, you can deploy on data centers if you want to. Another one is that we have a lot of customers that are using the public cloud, right? So AWS, AliCloud, and of course, if you're other major clouds like Azure, GCP, we want to provide services as well. And we also understand that we need to develop our community. So there's actually a community edition of OceanBase, and of course the enterprise edition. And then of course there's the public cloud version, which actually is the enterprise edition in the managed services. Okay. Now, this is an example I like to give my customers. Actually, I did this a couple of times already, the internal error 500, right? And it's as simple as you go online, I was doing this airline that I shall not name. I was with this example because it's really, really frustrating. It's midnight, you're talking to your friends and you go and book a flight, you go for your seats, your add-ons, the non-frills, cheap airlines always tag on a lot of services. So at the end of it, you say, okay, let's do a transaction, okay? And then guess what? It throws an error, right? That's really, really terrible. And it happens sometimes, not all the times, but sometimes. In that particular scenario, it happens not only on one payment method is that in fact I tried 3 payment methods, every single one of the payment methods have a different failure mode, okay? So rather than fail over, it fails all the time, right? So that's terrible. So you don't want to be in that position, right? And why that's something that I brought up is that imagine you are doing like one of those e-commerce festivals. So now we got a lot of like, you got August now, so you got 8/8, you got 9/9, 10/10, and then 11/11, of course, right? And every one of those festivals, imagine you're an e-commerce platform, imagine your payment, and suddenly you went from, 1 million transactions to 10 million transactions within the night, right? Normally, what everybody does is that they wait for the midnight to strike, right? They have everything in the cart, and they're going to transact, right? So imagine when they transact, and this is what happens. That'll be terrible for you. Okay. So let's talk about database disruption. Everybody says, okay, it's just database. Who cares? But actually, there's actual monetary impact, right? So if you look at this scenario here, you got transactional data loss, right? So imagine that you got a transaction, and then for 4 hours, your system went offline for whatsoever reason, right? The system went offline could be your database is reaching its maximum CPU, your storage is running out, or you encounter a failure within the platform that was not handled and was not filled over. So you lost 4 hours of transactions. Another thing is that you not only that you have that problem, that you also have to spend another couple hours to actually fix the problem. You want to identify a problem, figure out what happens, but imagine that you are actually going through a Double 11 festival. Every single minute that you're not doing business, you're losing money, right? And that's another downtime cost. And finally, imagine that you are me, with that airline that I shall not name, and I'm not transacting through them recently, right? Is that the reputational cost? So imagine you're a payment service provider, you're supposed to do the transactions, and it's double 10, it's coming, and then, in the middle of the night, you can't transact anymore, it's internal firing grid. And then, of course, your service provider will smart enough to say, I have a backup payment service provider, I switch over, and then, you actually lost that first off, you lost that couple of days of transactions. Second is that your e-commerce service providers say, I don't think I can trust you anymore, right? There's a reputation loss. So the ultimate loss for the 4 hours is not as simple as you lost the transactions, you lost the time that you want to fix it. You actually have a reputational loss, and it could be really, really significant. Okay? Yeah. So, next thing I want to know is what is the economic impact? So this is a very interesting topic. Is that a lot of people just look at the technology, says, I'm just using a technology, I'm just using a database. But there's a lot of different areas that you want to focus on nowadays. Scalability, right? So I talk about 1 million to 10 million transactions. Could your platform do it? Another one is that if you're not using a managed service provider like our OceanBase crowd, you can do self-managed. I have customers that do MySQL, Postgres. They do self-managed deployment. Imagine if your DBA suddenly says, I'm sick, and then your database goes offline, right? Another thing is that this is an actual question from my customers. Like customers, there's big customers. They say, okay, now I'm using one other service provider, and I want to move to another service provider. Is it easy for me to do? Or if I am now on the cloud, can I actually move back to the data center? I've had customers that actually ask this, and it is actually statistically proven and financially proven. If you have a turnover over $150 million, you have the capability to actually develop a data center that's more cost-effective than the public cloud, right? If you want an example, Dropbox is a great example, right? So they went from the public cloud back to data center, and they save a lot of money. So we want to give that flexibility to our customers. Another thing is about reliability and availability. Just as I mentioned, what you have one failure mode. How about multiple failure modes? Right? Can you handle it? Another one is that you want to look at the total cost of operation. I know MySQL and Postgres is free, okay, but there's always a price for free, okay. And the price is if something goes wrong with these 3 pieces of software, where are you going to get the support? And if you're running it on a self-managed, self-installed installation, if something is wrong, you don't really get your service providers come and actually help to fix it, right? You are going to use your database, the DBAs, your own sysops, right? They try to fix it. but there's no one else to help you. Okay, and finally, could you even like have a platform to do like data to value? It means that not only you're doing transactions, but you're also analyzing the data. So there's this new emerging terms called HTAG or hybrid transaction analytic. Could you do that? Okay. And of course, as an example, this is where we talk about platform and payment is such a massive topic, right? So payment is not just about the transaction between a buyer and a seller. Payment is actually a total platform by itself now. If I look at, this is just Alipay, but if I look at someone like GCash, TNGD, or even Dana in Indonesia, they're no longer talking about just a simple transaction. They're really talking about this is a platform. And can your database power a platform now, like doing financial services, handle a million merchants resources, and so on. So this is all powered by OceanBase. Okay. Yeah. And of course, this one, I just want to put it here. It says Double 11. We've been doing it for like almost every single year now. So this year is coming. Double 11 is coming. So we know that we can do this. And one of the unique things about OceanBase doing Double 11 is really the hybrid cloud concept. So not only that we could do it with the data center, but because Double 11, we need more resources, we can actually expand OceanBase partially into the public cloud. In this case, it's Ali Cloud, where actually the full transaction is happening on data center and also in the cloud. And when we finished doing this, we completed the Double 11 events. It's quite easy for us to pull back the database automatically into the data center. Yeah. Okay. So Dana have a different challenge. Dana have a challenge of scaling business 10x. I talk about like 150 million. Imagine when they started, it's probably like 50 million users, right? And they grew very, very rapidly into 150 millions now. And while they're growing, they really need to have ability to do high availability and also service availability as well. So with OceanBase, they were able to do 99.99 because the hybrid concept where partially we're doing it on data center and partially in the cloud as well. So this gives you a little bit of flavor on how OceanBase really looks like, and this is an example of GCash. So GCash used OceanBase to reduce the TCO because we could do consolidations. Now, the typical deployment for OceanBase is multiple nodes. It's typically 3 nodes and we form a cluster. But if you look very carefully here, first step is different tenants of the database. So initially you may have 10, 20, or even 100 databases spread across different instances of databases. But with OceanBase, you can actually consolidate it into a single cluster of OceanBase deployment. And it is fully isolated and independent. Another thing is, if you look at here, it says reduce consumption. So this is something that's proven. When I have a customer that comes to says, I have a MySQL database, RDS, and they have 7 terabytes of data. It says, it's really massive. And when you do a POC on us, it went from 7 terabyte all the way to 1.4. So this is a number that's substantiated, right? So not only that my POC substantiated, GCash substantiated that as well. And so in summary, right, again, right, so what we are focusing here on is that we provide a distributed database platform that you can scale. Another one is that you have the reliability as well. Just now you see that there's multiple nodes. So there's 3 nodes there. So even if just one of those is filled, it will automatically fill over and your transactions will not be impacted. We also allow you to do database scaling. Right? So just now you see 3 nodes. It could be 3 nodes, it could be 6, it could be 9, it could be 1,000 nodes. It's totally scalable. And I think it's about database storage, with real-time compression. That's great. And of course, what we really wanted to do is that if you start as a startup, you want to scale, we want to be able to support you from the time where you start your business to the time you get the size of a Dana. Yeah. So thank you very much. My presentation is over. So if you want to know more about how we can actually help FinTech and basically payments, any kind of digital economy services, feel free to scan this QR code. You'll get a really detailed, I think this is one of our best white paper that we have created so far. Really tells you about all the benefits that we talked about just now. Oh, okay, that's bad. Someone just showed me that it's an error, but no worries. We will send you an email on how to get it. Okay? Yeah, totally fine. We got failovers too. Okay? So let's move on. Finally, I think the rest of the...
Sorry.
Yeah, this would work. Okay, the rest of the QR code
sorry.
Okay. don't care about this one. If you want, yes, please, yeah. But you can look at our open source version, and it's available on GitHub. This is the GitHub location for OceanBase. And if you're interested to participate in our community, you want to talk about OceanBase, once you start using it, feel free to join the Slack group as well. Yeah. Okay, my presentation is done. Thank you very much for the time.
Do anyone have questions? No. Oh, no.
Yes.
No photo, please.
Okay.
So, thanks for your very crisp presentation. I have a question on because you're on very large scale, and you actually also deal with RDS. So, what kind of what do you call? I won't even use the word backup. What kind of resilience you have for memory leak?
Memory leak. First off, we are.
You worry because judging from the scale and also from the quantity, some of your processing will be on memory. I imagine.
That's a very good point. So
and also, who manages all your endpoint, and when it is. I believe it could be a managed service or maybe your in-house or third party. So how do you prevent this kind of external threats?
Okay. So external threats, if it's not managed, I can talk about it. Because
if you because it can be inside as well. I come from a cybersecurity background. So this is the kind of question.
So I just want to focus on the managed services first, because that's something that I can answer, right? First off, we go through compliances. We go through SOC.
Okay, compliance and risk is GRC and security are two different things. So when you are secure, it doesn't mean you are compliant. You are compliant, it doesn't mean you're secure. So you can be secure and compliant at the same time. So how do you tackle this for this game?
Yeah. So first, let's tackle that memory leak thing first, right? First off, I think all software development, right, when we go through the development life cycle, that's the first thing that we do. And the reason is that for OceanBase, we are actually a memory-first database platform. And the reason that we can do a lot of transactions in a very fast time is that because the database is designed to be memory-first. So that means, the transactions, the queries, it's all actually from the memory, right? But that's one. Second is that the question would be like, okay, if it's memory based, what if you switch off the machine and then you can lose data?
And also, hardware can have failure on this.
Yes.
When it's intensive processing and HA, so this thing can happen quite often, actually.
Yes, correct. So in order to handle that kind of failure modes. There's two different issues here. One is that actually every time you do a transaction, actually a log is being generated. We call it C log. Yeah. So this is very standard for any database systems, right? So whenever I say a transaction is completed, especially if it's in memory, I still have to record it because that helps you to comply to ASIC compliances. Yeah. So it can't fail, right? That's one. Another one is that you mentioned about if you're under high pressure and then you start to have some kind of failure, whether it's hardware failure, software failure, whatever it is. Because we got 3 nodes, right? So it's high availability. So if one of the nodes are encountering some issues, and I have that experience myself before. I got 3 nodes, and one of my benchmarking tools that I wrote that really hits the node really, really hard, and then node starts to fail, right? And when it fails, actually, OceanBase will detect that this node is overutilizing. It actually starts to switch over to the other nodes, right? So there are resiliency built in our design to actually do the failover. Okay. Another thing is that about cybersecurity, about threats. Most important of all is that there must be check and balances across your whole single chain of data management. Yeah, it's not just. That's why I said I cannot talk about if you have self-managed database, you install OceanBase yourself. First off, I don't control your sysops. I don't control your DevOps. So
that's why because this is very important because we are talking about community edition. It's a different ball game from enterprise solution. Yeah. So these guys, they cannot do this because they are not equipped for this kind of knowledge to manage this kind of service.
Right.
So in that aspect, what is your offer to help these toolkits, I call.
So that is why for customers that's like, you want to focus on your startup, you want to focus on developing applications, you want to use managed services, right? And the reason you use managed services is that managed services have a lot of these securities, data protections built into the service already. That's one. Another one is called a big glass concept. So if you use services like managed database services or even AWS, I'm ex-AWS, we all do the same thing. There's a big glass concept. That means that the engineers that's running the database platform have no access to your data, right?
But AWS is half-half, They do have control and the customer have control.
Yes.
That's from AWS mouth.
Yeah, no, but that makes sense. Is that you control your data. I don't control your data. You control the encryption key as well. You can have your own encryption key. You can encryption the data. So if you go to us,
API key, who keeps them?
You keep it. I don't keep it. Yeah. So I don't have any access to your data.
Sure.
Yeah. So that managed database service, I can tell you. But for unmanaged, like you install your own OceanBase, you want your own database operations, you want your own security. I can't, because I can't control your people. Yeah. I hope that answers your question. Anyone else? Oh, it's not a challenge at all. Okay.
Yeah.
Thank you.
With that, today's warm-ups comes to a close. This kind of meetup will be a regular occurrence happening monthly. Be sure to follow OceanBase LinkedIn account for updates. The last thing, let's take a picture, okay? Thank you, everyone. Yeah. Tommy, let's take a picture. Thank you. Okay. Let's take a picture. Thank you. Okay.
哎，谢谢，辛苦了。还好要跟你再请教，多分享点。
Hello.
这边先吧。
1, 2, 3. Okay. Thank you.
Hurry up.
I think they need some female representation. It's too much of a male space now.
Oh.
I'm not
Sorry. Yeah.
Ready? 1, 2, 3. Awesome.
Thank you. Thank you.